All right, so it should be on. I guess it's working, so you don't have to confirm it. But today I'll be talking about how we are building an API-first software in CakePHP 4, because that's one of the main attitudes that we're working with, or that we're developing software as. So it's sort of like that we have a full backend stack built with CakePHP, and then we are building various different front ends on several platforms that are completely unrelated to the backend, that just use the API, and that is completely separate platform. So the content for today is I'll talk about a business background for the project, which is sort of a hypothetical project. So it's going to be a little bit of a business talk. Then I'm going to explain how we closely binded the backend and front end using API and something that's called a Swagger, which I presume a lot of you know, but some may not. I'll talk about how to connect the backend to complex algorithms, because that's one part of the application, which I'll explain in the business section why we are doing this. Then we are integrating the system with the contact center. And last but not least, we're writing the backend in CakePHP, so we look into what's necessary to do when we want to implement the backend part. So a little bit of business talk. First things come, that what's the background of us, what we do. Currently, I'm working at Daktela, as Amanda introduced us. I'm working there since 2018. I'm working in the position of Chief Technology Officer, and I've come in contact with CakePHP about 8 years ago, when it was still in diapers, or with the version 2 point something, where nothing from the 3 or 4 version was not born yet. What our company does, we are existing since 2005. We built contact center system as a service. It's a web-based graphical interface which the contact center of our customers just receive for the agents, and they can use pretty much any channel to contact their customers or to talk them with, which means that the customers can call them, they can handle their emails, the SMSs, web chats, Facebook messengers, WhatsApp, and several modern channels as well. Currently, we have around 120 people, and in our division in technology, we have around 50 people, which are mostly dedicated to development. We have 3 development divisions, and I'll be talking about one of them mostly. Here you can see our technology stack that we are using. You can see that it's pretty rich, that we are using a lot of modern technologies. But one of the core of the ISD team, which stands for Integrated Solutions Development, which generally means that we are developing systems on top of our main product, the contact center system. The heart of this this department is the CakePHP framework. We currently have about 3 or 4 projects running. One of them is the COVID-19 tracing as well, but it's been sort of like sideways lately, because there's no more COVID-19 fight these days anymore, just some units or some single cases. But one of the projects that we are currently developing or working on is the shift planning solution. So that's what we will be talking about. That's what I'll show the architecture on, and how to implement the architecture in real life. In this department, as I said, we're primarily using CakePHP. We're using the CakePHP 4 on all projects already. It's built on PHP 8. And we use several supplemental technologies like MySQL 8 for the database. We use Redis for key value caching. We use RabbitMQ, which I'll show as well how to use it, and we use React for the front-end part. So there's gonna be no front-end part for CakePHP on this presentation, actually. What's the project about? How does it work? Just briefly. It's a shift planning in contact centers. It's actually a pretty complex job, because contact centers have a lot of interactions. They have a lot of combinations of skills. Agents have different competencies, and they know how to handle customers differently. You have many channels that you need to handle. So you need to somehow plan this in some sort of software. It's not possible to do it by hand manually, or it's not definitely optimal. But most or a lot of contact centers these days still use Excel to do this. But I think that the predominant way of doing this is now implement some sort of system for this. So that's why we are working on this actually. There are some subtasks that we also need to handle to have some sort of optimized model of the planning for the shifts. There are 2 very important parts, and that's why I actually said that we're going to be talking about how to implement the Python or some complex algorithms in the backend. The first one is that you need to have some sort of traffic forecasting. We will actually be using some AI, some machine learning for this, some prediction models, which we actually learned this summer, how to use it and how to implement it. And then we'll use some complex fitness algorithms for finding ideal allocations of the agents into shifts. So generally, there are 5 steps that we need to do, that we need to implement in order to perform shift planning for a contact center. The first one is that we need to import the traffic from previous periods from the contact center system so that we have some basis of data on which we can work on. Yeah, so this means that we need to connect to the contact center system. We need to import the interactions, calls, emails, and so on, and get this somehow into the system. Then there's the second step where the AI and machine learning comes into place. We need to forecast the traffic, how it will look for the next month. Based on this, we need to generate needs. This means that we will tell the contact center how many agents they need for each interval. We will be using 15-minute intervals for this. So this means that it will say, on this scale, on this project, you will need, for example, 4 agents to handle calls. Yeah, so this is really like looking into the orb, you know, looking into the future, how in the next month the traffic will develop. The fourth step is that we need to somehow optimize the traffic. There are several inputs that you need to consider. You need to consider the needs that were generated from the previous step. You need to consider the holidays of the users. You need to consider their contractual values and some employee laws. You need to consider their preferences when they want to go to work, for example, if they want to have night shifts or not. And you need to put all this together in some sort of soup that will result in having the shifts planned, and you know, the contact center will receive the full shift plan for the next month. And the 5th step is, it's there actually, it needs to be implemented, is shift swapping. This means that the agents can swap shifts between each other. For example, if I want to go on Friday to work and someone does not, and he has a shift planned, I can swap with him using the interface. And definitely we need to enable the administrator to manually, for example, fine-tune the shift plan and alter the plan and change the shifts as he deems necessary. So technically, what are the architectural goals that we have for the project? Firstly, is definitely a split between backend and frontend. We want to have all the business logic on the backend side. Definitely, there shouldn't be any business logic on the frontend. That's for sure. It's ideal that the backend developers are working on backend and they don't really need to open the frontend part of the application because it's in different technology. It requires a different skill set. Some similar thing applies for the frontend as well. So frontend has all the presentation logic. There's no business logic on the frontend part. And just like the backend developers, the frontend developers are the ones just working on the frontend. They don't open the backend parts or the backend files at all. We need to consider that there might be more front-end implementations in the future. This means, for example, if we decide on having mobile application written in some different technology, or that maybe some customer writes his own front-end for the application, we need to consider this as well. It's preferred to have the single-page application framework or the logic implemented because it definitely improves user experience. And one thing that we really focus on in all our products is that we want our customers to be able to integrate to the product. So we want to provide them with easy and powerful REST API. Generally, what we want to do is that whatever our graphical interface or our front end does with the application, the customer should be able to implement this as well using REST API. So from architectural point of view, the front end is actually using usually the same API as we provide to the customers within the API documentation. It's pretty open attitude from us. We have, I'd say, 3 architectural options on how to build the application. First one is the pure PHP model, which means that we will have, just like we know it from the standard MVC application, we have the backend in PHP 8, we have the front end in PHP 8, which is like pretty statically generated. We can use some JavaScript to make it more dynamic. We can have the hybrid model because we want to provide the API. So we have some sort of similar situation, but we, for example, write an API controllers or use some API space with specific controllers to provide our customers with the API. The disadvantage is definitely that if you maybe you write some logic for the backend and front end part, for your application, but if you want to provide it to your customers, you need to write it, I'd say, second time or somehow implement the second time for the API. Or there's the third option to have some sort of automatized means of implementing the architecture, which means that you have the backend in PHP 8, you have some sort of generating or creating an API, which is then used by the front end and provided to customers as well. So definitely we'll be going with the third option. That's why we're here actually on this presentation. So we'll be using the separated backend and front end, and that's when we'll be using the CakePHP on the backend and generating the API, and then there's some front end which will be in React this time, but that's not something that I will be going very deep in this session. How does the architecture look like? What we'll need. So as I said, there's a backend, there's front end, there's some sort of REST API. On the backend, we'll be using PHP 8, which is obvious for these days when you're starting a project. We're using CakePHP 4. We will be using Redis as a key value storage. We'll be using Python for the complex algorithms I described, which means for the AI, for the machine learning, and for the fitness functions. And we'll be using Rabbit messaging queue for communicating between some of these platforms, which I'll show later on. We'll use Swagger for generating the REST API and then for consuming it as well. And on the front-end part, we'll be using Bootstrap to have a responsive first interface. We'll use React for this SPA framework. We'll use Storybook, Figma. I'm not going deeper into this, but generally it means that we will be able to connect the front-end developers with the UX developers so that, you know, when the UX developer draws some screens in Figma, draws some components, they can just import it into React, just generate the code and then use it. So the front-end developers really don't have to develop that much from the graphical part of the application. And then we are using Cypress for the front-end testing. So the first part is the implementation of close front-end and Swagger binding. I'll start from the front-end part because that's one of the I'd say easiest or smallest. So what's ReactJS? It's today, I'd say, the most popular framework for front-end. It uses mainly TypeScript, which is sort of like an expanded JavaScript, and it's developed by Facebook. On the other hand, Swagger, it's or OpenAPI, it's a standardized format where you can just write some JSON, how your API looks like, what are the methods, and it generates some sort of nice UI you can provide your customers or some developers who are implementing on your application. And it strongly supports automatic generation of code. So you can generate tests, for example, you can generate some integration libraries and so on. So it's really built on generating something that's automatically consumable. So we'll be using this for connecting the front end to the backend part. How do we do it? So in the project, what we are using is, there's a library which is called CakePHP Swagger Bake. It's something that really helps us automatize all the tasks. How do we implement it? So first step is that you just put it in the composer. You initiate it in the application PHP file in the Bootstrap part. You just load it as a plugin. So this add plugin Swagger Bake. Then you create a configuration file in the config directory where you configure what's the JSON you want to generate on the file system, what's the configuration input which you will use for the Swagger generation file, and then you set where the file should be accessible via the GET request via HTTP, where it's publicly accessible. And you can also use the hot reload option, which means that it's automatically generated once there are some changes in the models, for example. And you prepare a twig configuration on how the controllers look like, so that it pretty much knows how to read the annotation that we will place in the controllers later. How it looks in practice. For example, this is one controller that we are implementing. We have a public method which is in the prediction controller, so it's prediction/train resource. You just one of the part is generated automatically, but you can annotate a lot of things using the library. So you use this notation where you just say, for example, what are the parameters that you can use, what are the examples, and then you have the method body, you have the action body, the code that's executed. When you run the Swagger Bake, it automatically generates sort of like this. Yeah, so we have the API/API, which is the root for the API. We have /prediction/train, which is the controller in action. And then you have the methods that are usable for this. Yeah, so you can see the request body contains the variant, which is this parameter, and the QID, and you can actually see that it generates examples, typing, and so on. Yeah. So just by annotating the methods, the actions, and using some sort of automatic logic that comes with it, you have like a really big Swagger JSON file that can be automatically consumed by some sort of front end. So this is available under the /Swagger JSON, which is the path that we've configured in the web root, in the config file. So it's /Swagger JSON. You can definitely customize it. And there is also automatically created other thing that can be provided to customers or to other developers /Swagger. So it's automatically generated Swagger UI. So you can see it's the same method that was in the JSON section. So you have the API prediction train. So the API prediction train, you have the example or the request body parameters. You have the possible responses, which are generated from the exceptions that are thrown, the standard CakePHP HTTP exceptions, which come with some response codes. So this is something that you provide to your customers. Yeah, you consume the JSON by yourself or by applications, and this is also automatically generated, and this is what you provide to other developers, to your customers. And all this we've done is or happens completely automatically. When there is a change in model, when there is a change in controller, there's very little work that needs to be done by hand. You have the API documentation available pretty much automatically. How do we consume this in the front end? I don't have the actual implementation in our application, but this is just to illustrate. There is a package Swagger TypeScript for in the npm, which can be consumed by Yarn, for example. You just configure the URL of the Swagger. You configure where you want to generate the TypeScript source files in your project, and you just run the generate function, and this actually creates the TypeScript files in your project just according to the Swagger documentation that was generated. So the end result is that what your backend developers do in the models, in the controllers, in using annotations and some auto-generated code, pretty much automatically is reflected in the models that are implemented on the front end side. Yeah. So it's really useful that you have front-end developers who don't understand the backend code. You have backend developers who don't understand the front-end code, but they are all using the same methods. They can communicate what's possible, and they are using the same models and attributes, and they don't need to really study the documentation that much. They are just using the typical autocomplete function that we know, that we all know as developers. That's something that's really great. So when you want to access some attribute from some model, from some object, it's all suggested to you by your development interface. Second subpart: how do we connect the backend to Python algorithms? Because we have, as I said, we have the two or at least two algorithms that are pretty complex, that are written in Python, and we need to somehow interact with Python and backend, together to make it work together. So for the Python scripts, there are two of them. We have the machine learning traffic prediction. It's a Python script. Because it's a machine learning algorithm or prediction algorithm, they usually work like that. You train it on some data set, and then you just run it on test data set. So there are like two subtasks that need to be run. The first one, training the data, it actually takes minutes to hours. So it can be really long. It needs to be asynchronous, and it needs to be somehow done automatically on background. We will be doing this actually once you authorize the connection to the contact center system. We will start the job somehow on backend asynchronously so that it finishes in some time. We don't really connect it to the graphical interface for the user, or it's sort of like a connection that when the user checks if it's already downloaded, we just show it, but there's no like publish subscribe implementation or something like that. Then there's the generating prediction. It takes several seconds, so we will definitely do this synchronously, synchronously with the graphical interface. So when the user requests the prediction, we just wait in the graphical interface for it to complete. As for the second script, is the fitness algorithm. It's a Python script, and it takes literally hours. It's really long. Currently, it's, for example, I don't know, 24 hours could be. Maybe you're shortening it down to 4 hours or something, but it's really long algorithm. So it needs to be done completely asynchronously. Why are we using Python for this? It's pretty good for algorithmizations. It doesn't add that much to the code. It has a really small footprint. It has a lot of easy to use libraries that are already prepared for the purpose that we want to use them for. And these days, it's pretty much the generally main language for machine learning and AI. And pretty much anyone's doing something with AI, they're doing it in Python these days. So what do we need to do in the project? We need to ensure that there is some connection between CakePHP and Python. It needs to be synchronous and asynchronous. So there are two types of connections. For the synchronous connection, we could definitely just trigger the command with some sort of like exec function or something like that, but I don't think it's really good practice to do it. It's sort of like a dirty way. So we're looking for some sort of message queuing solution where we can just connect both ends to the pipeline and communicate between these two platforms via some, I'd say, API or something like that. The solution to this is RabbitMQ. It's a message queuing daemon, which means that you can create several queues in which you can send messages to, and you have like many platforms communicating or connecting to this pipeline and consuming and publishing messages to this. It pretty much enables synchronous and asynchronous logic, so it's pretty ideal for our use case. And it can work on publish-subscribe models, so it's pretty easy to, for example, send something and wait for the reply. It can actually, like, ping you back when the result is available, and so on. So how do we implement this? The machine learning part will occur, the training part will occur on cron rules. So this means that, there's some sort of cron or maybe daemon which runs continuously and picks up tasks to complete, and just when the job is finished, we will upload it to database and then make this accessible via a graphical interface. The prediction, because it's really fast, it will run synchronously using the message queue in sync mode, and the fitness function will run asynchronously just as well using the messaging queue. What we need to connect together. On one side, we have some sort of action in a controller, which we need to use to call the Python scripts. On other side, we have this pretty easy Python daemon that's running in an endless cycle, and it's just consuming messages from the Rabbit messaging queue. The connection looks pretty much like this. We have a sort of send request function on the CakePHP part. It's always about creating some message queue message and publishing it into some queue key, so predict queue, and we just send it as a JSON form in JSON format. So we say, for example, what's the callback queue, what's the correlation ID that we need to use, and just put it into RabbitMQ using this package, which is amqt lib in Composer, and just wait for a response. Before there's a response, we are waiting for the channel response. On the other side, we have, as I said, the daemon waiting for the messages, and we have an implementation of receiving the message. So once the message is sent to RabbitMQ, it automatically is received by the Python script, and the callback function is run on this message. So the Python can use these two parameters to work with and to process them. So then there's some business logic that happens. We predict, for example, the forecast or the traffic for next month, and we need to somehow give it back, which is pretty much the same, but in reverse order. So we publish it on the Python part, we push it to RabbitMQ, and then we somehow process it in the CakePHP side. So this is the synchronous request. We were waiting for the result, then we published the JSON response after the result was published. If you want to have an asynchronous call, you need to have definitely some sort of daemon or some sort of callback script that is run after the message is delivered, after the job is finished. So using the RabbitMQ, we've implemented the communication there and back. We can call the Python logic and have the results pushed back using RabbitMQ to CakePHP side. Then there's the subpart how to integrate the contact center system. This is actually fairly easy thing to do. We love REST APIs in Dactyla. We are pretty open to integrations. Because we need data from Dactyla v6 and maybe push something back to Dactyla, we will be implementing this system, our system, of course. We're lucky that Dactyla v6 has native REST API. It has an API documentation which looks like this, and we're also lucky that there is a PSR compliant PHP library available by in Composer. So it's fairly easy. We just include the library in Composer, and we call some logic. We initiate the communication, build the read request, execute the request. We can filter out the activities, for example. So this is how we load the activities from 1st of November 2020, and we just process the data. So this is all the connection in CakePHP to the CC system. So this was the easy part. So let's dig into CakePHP and write the backend. Let's do the project as a whole. For the project basics, we will definitely use CakePHP 4.4. We will install all related Composer libraries, which means migrations and plugin installer. We're using migrations pretty much for all of our database. There's nothing beside this, so we're using the things library for this. We also installed the Composer libraries, which I mentioned in previous slides. So this means CakePHP Swagger Bake. We will install Dactyla v6 PHP connector and the PHP AMQ plib. That's the correct name. This is the entire list of the libraries that we'll be implementing in the project so far. We use PHP CS for the style rules or rule styling, and we'll be using Docker for the development environment using Docker Compose. I have a brief slide on this. We are for all our development environments, we're using Docker Compose. The production will definitely run on some sort of private Kubernetes cluster because we have our own data center and our own infrastructure team. We can also use Azure, AWS, GCP as well because they all provide the Kubernetes clusters. And we definitely are using CI/CDs to deploy this into production and even for the development environments as well. As for the development purposes or the development environments, we're using several containers. We're using all these containers to work with, which are orchestrated by Docker Compose. So we use web server where Nginx and PHP FPM is running. We use database, a MySQL image, Node for running the front-end side, Python for the prediction or training, for the algorithmization, Adminer for access to the database, Redis for the key value storage, RabbitMQ for the messaging queue, and Mailhawk for testing or for mocking SMTP communication. So you just create a Docker Compose file which contains all these containers. So for example, this is how you define Mailhawk, web server, database, what image is the source, how you will load some environment variables, how to load the volumes into it, what ports should be published to the computer, to your PC, and so on. And if you do this correctly, there are just 2 steps for you to do when you clone the project to your local PC. You just copy the .env example to env, you alter the variables just as you wish, and you run Docker Compose up, and it actually starts all the services automatically. And that's all you need to do in your development environment altogether. Once you have this, you have some sort of local host, port 8080 or something where you can develop and work with. For the models, we pretty much just bake them and somehow alter some things in them, but there's not really much logic for us to do on this side. We of course have some custom logic on the users table, for example, how to hash passwords or some custom finders, and that's pretty much it for the model side. As for the controllers, we are using some sort of abstract CRUD controller, which means that there's a lot of CRUD logic, on the model side. So we have one parent for all of them, which is abstract class, and the users control workplace and other controllers where we want to perform the CRUD actions, just extend them, and they, for example, define what table they are using, what model they are using, and so on. But the abstract CRUD controller implements the basic actions like delete, index, view, add, edit, and generally all the resources that will be connected in the API will use these methods, just using different model for communication with the database. We also configure resource routing, classic JSON resource routing in routes. So we implement we said that the extension is JSON. We apply out middleware. There's some sort of code that implements authentication middleware on top of this as well. And then we just say what resources are available via the API, what actions are available on them. We have some private class or some custom-made class which creates the configuration arrays for us, but in clean code this would be just an array of configuration. And we have some generic JSON response methods. Yeah, so we have success method for JSON response, we have error method and others, which we push to the HTTP request as generic methods. So we write the CRUD actions in the abstract CRUD controller. So this is for example, the edit action. This is the get table patch entity. This is pretty much all the business logic that's in there. And if there are other API actions, we write them in custom controllers. So for example, if you have like a prediction controller, predictions controller, we can write our own actions which are not CRUD, because it's pretty much split into CRUD actions and non-CRUD actions. The CRUD actions just, there's some sort of UI to edit the objects in the database. And then there are some specific methods, for example, to show some schedule, to run the prediction, and to do some non-standard CRUD stuff. So you just write the methods, and the Swagger actually automatically generates, the documentation for them. You can annotate them if you want. As for the views, there are no views. The views for us is the Swagger UI and the Swagger JSON. So the Swagger bake automatically generates the Swagger UI and Swagger JSON, as I've shown. You just call the /Swagger JSON for the machine readable API, which you can implement in your libraries, in your applications, or if you want to load the API documentation in UI, just load the /Swagger in your browser. So this is how the result looks. This is documentation of the workplace's resource. You have all the get, post, get, the list, the create, the view. This is the change, edit, delete method. So this is all documented with examples, with attributes, and you also have the models, available like this. You have the data types, examples, and other attributes, and also you have this, as I said, generated in your front-end application. And then you can start consuming the API. So you just call the /API users. You use some attributes that are available in the abstract CRUD controller, and here you can see in Postman we just received all the data. Everything that's available in the model that was generated using the Swagger bake command. So that's pretty much it. Thank you for the attention, and I guess we have a lot of questions in Slack.